Okay, so class, I need you to get out your exponential notes and open them up to the one section where we start. So the back of the first page down at the bottom. Gonna give you guys 30 seconds. Okay, class, back together. So here we go. Key concept, exponential growth and decay. So with exponential growth, this is what's going on. We are going to be modeling with the growth and decay. So this is the general form for an exponential, a times b to the x. So here's the thing, this is the same formula, it's just tweaked slightly. You still have an a value, which is your initial amount. So I'm going to arrow that and go initial amount. Okay, r right there is your rate of change. Okay, and with that, with your rate of change, it can be positive or negative. T is your time for some time, and generally it's like a number of periods, number of time periods. Okay, and then what this equation equal to over on this side is your amount after your time. Okay, what you guys need to remember is this part right here lines up with my b, there's my a, and then I have my x. So my b value is equal to 1 plus r. Okay, where r is your rate of change. Your rate of change can be positive and increasing, then we get to a growth. If your rate of change is negative, it's going to be decreasing. For growth and decay to be exponential, right? For both growth and decay to be exponential, a quantity must change by a fixed percentage each time. So we either are going to be increasing or we are going to be decreasing. So you guys, when you're talking about the growth factor, your growth factor is 1 plus r, right? R is generally given as a percent. Sometimes it is not. So here's the thing. If you say, so if I had a value of 2, I get 1 plus r. So r then is equal to 1 when I solve that, and it's increasing by 100%. So when we talk about the decay factor, right, decay is usually expressed as a negative quantity. Right? So instead of being positive, you're going to get r minus, excuse me, not r minus 1 minus r. 1 minus r. And that's going to be equal to your b value, because if it's decay, I'm not increasing, I am what? Decreasing. So this one, decrease, is a word that means decay. All right, so then we have these 3 examples on the next page. We got around 5 of them. So use the property of the exponents to identify the percent rate of change of the function, and then classify them as representing exponential growth or decay. So I come down here. So I got to decide if it's growth or decay. So looking at this, it's bigger than 1, so I know it's growth. Here's the thing. 1 plus that rate should give me 1.02. So to solve for my rate, I can minus 1 from both sides. So I know my rate is 0.02. Converting that to a percent, which is just 2%, right? Both of those would be okay as an answer. You can also think of it 1 plus r is equal to 1.02, so I just need to add 0.02 to get it to match. Over here, am I growing or decaying? Well, that is less than 1. So I am decay. So here's the thing. 1 minus r should give me that 0.88. So I know 1 take away something should give me 0.88. So few ways for you guys to do this, to swap it around. So if I go 1 minus 0.88, that is equal to my R value. So R is equal to 0.12. That's one way to look at it. Switching stuff around, you can go plus R to both sides, right? So you get 1 is equal to 0.88 plus R. So I need to minus that 0.88. And you're going to get R is equal to a positive 0.12. But here's the thing. I'm decaying, so that is a negative 12%, right? I am going down, so this is a decrease. On my next one, my B value is 3, so I'm tripling each time. It's bigger than 1, so I know I'm dealing with growth. And here's the next piece to that. Since I'm dealing with growth, 1 plus my R value is equal to 3. Well, what value do I need to add to 1 to get myself to a 3? R is equal to a 2. So I'm increasing this one by 200%. So what is the percent of rate of change of this function? So let's look at this. Is this growth or decay? It's bigger than 1, so I know it is growth. So here's the thing. 1 plus my rate will give me 1.03. So I minus 1 from both sides. I know my rate is that 0.03, which is 3%. Over on my next one, this function that I have, f of x is equal to 80 times 0.2x. So then coming over here, that's my initial amount. I come in right here, 0.82. So I know this. It's less than 1, so I know I have decay on my B value. So I got 1 minus my rate should give me 0.82. So a way to think of it to get my rate, 1 minus 0.82 should give me that. So 1 minus 0.82 should equal my rate, because those two, that goes to there and that goes to there with solving with algebra. 1 minus 0.8 is equal to 0.18, and as a percent, that is 18%, and then I would say, right, decrease or decay. Next one, explain how you can tell if it's going to be exponential growth or decay. I look at my B value, right? If it's bigger than 1, it is going to be growth. If it is less than 1, it is what? Decay. So here's the thing. Assignment EP 4.2, you guys are now going to work on the first 10 problems, problems 1 through 10, giving 5 minutes.